Hey guys, welcome to the Level 1 MCAT 2018 paper. So this is day 2's paper, and as usual, what I'll be doing is I'll go through the whole paper with you guys. Some recommendations for this video is at the start of each question, just pause the video, try the question out by yourself, just to see how far you actually go with the question. And then, of course, just check out my answers just to see what I've done. All right. Especially even for those really long questions, just make sure you have a go at it before watching the video. Okay, so let's get started. So the first question that we had is this one here, where we've got a formula and we've been asked to give the equation for R in terms of A. So basically what we have is we've got a question where we need to rearrange everything. All right, so I'm just going to write down the formula first. A equals 25 over 9 R squared. I've got to get rid of the 25, 9, and the squared. So I'm going to start doing one at a time here. So the first thing I'm going to get rid of is the 9. So when I cross multiply the 9, it becomes 9 times A. So 9A is equal to 25R squared. And then the next step is I divide by 25 to get rid of the 25 on the right hand side, which is going to give me 9A over 25 equals R squared. And of course, if I want to get rid of the R squared, I can just write this as 9A over 25 and a big square root symbol like this. All right. And also remember that when you do take a square root of a number, you always have to have a plus or minus in front of it. Particularly in this case, you can actually leave your answer here. Now, some of you might actually see that you can actually take square root of 9 and square root of 25. So you can actually write your answer like this as well. We have R is equal to plus or minus. Square root of 9 is 3. And square root of 25 is 5. Square root of A, can't really do anything with it. So we just leave the answer as it is. All right. So any one of these is going to get you a achieved. So that means getting up to here will get you an achieved. Getting up to here will also get you an achieved. All right, let's go to the second question. So question B, what we have is find the value of x if 2x minus 1 equals 64. Now, I always say this to people. Whenever you have a look at this questions with exponents and you've got the basis that's already given to you, when I say base, I'm talking about the number 2 here. What I generally like to tell my students to do is write down the 2 to the power of those numbers so you can kind of start working on it straight away. So on the side here, what I'm going to do is 2 to the power of 1 is 2. 2 squared is 4, 2 cubed is 8, 2 to the power of 4 is 16, 2 to the power of 5 equals 32, 2 to the power of 6 equals 64. And I think this is what I'm looking for here, that 2 to the power of 6 is equal to 64. Because what I'm going to do is I'm actually going to replace the 64 and I'm going to rewrite it with the base of 2. So this whole equation now is going to look like this. 2x minus 1 equals, and instead of 64, I'm going to put down 2 to the power of 6. Now, because the two bases are the same, I can almost, I can fairly confident and say that the powers have also got to be equal each other. So that means I just forget about the base and I rewrite this as x minus 1 equals to 6. And then here you can kind of just say x is equal to 7. I mean, you don't need to do this whole 6 plus 1 part, but just to show you where that 7 comes from. All right, so as for this question, it looks like it's an achieved question. And I think it says correct solution only, no alternative. So that means you got to get the 7 to get an achieved grade. And it also said that you can actually use guess and check method for this particular question. All right, so let's go to the next one. So question C here, what we have is we've got a couple of algebraic fractions and we've been asked to write it as a single fraction. All right, now looking at the fractions looking at the denominators, x minus 4 and x plus 1, there's not really any kind of common factors. So this is a straightforward cross multiplication question. All right, so that basically means what I've got is I've got 3 multiplied by x plus 1, and I've got that plus there, which is kind of written over that red mark, but 5 multiplied by x minus 4. And of course, the whole thing is divided by x minus 4 times x plus 1. Okay, so this is not going to be enough, but we do have to actually have just have to expand and simplify things here as well. All right, so I'm going to look at the numerator first. So with the numerator, I'm going to do 3 times x and then 3 times 1. So I've got 3x plus 3 plus, then I've got 5 times x and 5 times negative 4. So 5 times x is 5x. 5 times negative 4 is negative 20. And as for the denominator, I expand the quadratic. So I've got x times x, which is x squared. X times 1, which is 1x. Negative 4x. And negative 4. So simplifying this, collect my like terms. So I've got 3x and 5x, which is going to equal 8x. Then I've got my numbers, plus 3 and minus 20, which equals minus 17. And as for the denominator, I've got x squared, and of course I've got to remember the x and minus 4x, which is going to equal minus 3x minus 4. So for this grades wise, you can get a merit correct statement with numerator simplified. So if you simplify the numerator, you can get a merit. The denominator, it says that it doesn't need to be expanded. So you could have actually left the denominator like this, which means you can still get a merit. For achieved correct arrangement of numerator or simplification of numerator. So I guess we could call an achieved here, or consistent simplification. So if you make a mistake and you kind of like go all the way down somewhere here and you've got a wrong answer there, you can potentially get an achieved for that as well. Okay, let's go to the next question. Okay, so question D here, we've got area of the right angle is 65 centimeters squared, and what is the value of x? We've been given a triangle here. So the first step is, you gotta remember some of the basic formulas like area of triangles, square, and rectangle. So area of triangle is half multiplied by base multiplied by height. So let's have a look at what are all the things we know. We've got to try and figure out what x is. Now, I know there are people out there that will look at this problem and go, oh yeah, I can just guess and check. Just having a look at the exam schedule, actually no, if you look at the actual question itself, it says, remember you must use algebra and justify your answer. So guess and check is actually not going to work for this particular question. So let's have a look at what we know. We know the base is 6x minus 4. So that's what I'm going to replace b with. We also know that the height is x. So I can replace h there. And there's one more thing that we know, which is the area itself. We know the area is 65 centimeters squared. So what I'm going to do is I'm going to rewrite everything. I'm going to write that as 65, because that's the area, equals half, times base, which is 6x minus 4, multiplied by height, which equals to x. And now it's just a matter of rearranging this into a quadratic. So what have I got here? Let's see. Because I've got half times 6x minus 4, I'm actually going to kind of simplify that. So what I mean by is I'm going to do this. 65 equals, because I can actually do half times 6x, half times negative 4. Because when I do that, half times 6x is 3x, and half times negative 4 is negative 2. So it's kind of doing some quick work, really. It's just another way of doing it, that's all. I think if you guys have a look at my day 1 video, the same question, I do it in a different way. So if you get a chance, have a look at it. But yeah, both ways are still going to get you the right answer. So in here, I've got 65 equals this. So I'm going to have to rearrange or expand the quadratic. So 3x times x is 3x squared. Negative 2 times x is negative 2x. And of course, I want this to, one of the sides to equal 0. So I'm going to put down 0 is equal to 3x squared minus 2x And of course, when the 65 comes to the opposite side, it's the opposite symbol. So opposite of positive 65 is minus 65. So at this rate, what I've got to do is I've actually got to factorize this. So having a look at this quadratic, I'm not going to lie, this is actually a really ugly quadratic in terms of numbers. But, you know, this is what we've got, so we've got to actually deal with this. So if you've actually watched some of my previous videos, you will actually understand what I'm doing here. You can actually guess and check the quadratic equation here to try and factorize it. That's one way you could do it. If you know the quadratic formula, you can also use the quadratic formula here to try and get the two solutions. That's not a problem. But yeah, a lot of you might have actually done this this other way, which I'm going to kind of work around right now. So let's have a look. What we have here is we've got 3x squared minus 2x minus 65 equals to 0. So what we end up doing is we actually go 3 multiplied by 65, which is 195. And basically, you're looking for two numbers, sorry, that's also minus 195. Two numbers that multiply to minus 195, and they've got to add up to minus 2 as well. 195 is an ugly number. I mean, I'll be honest, it's like if you say this question to me, the first thing that I do, even though I've been doing maths for so long, it's like, man, this is just an ugly number. That's the first my thought that comes in. But how do I do this without a calculator? Okay, so one thing that I like to do is like I actually write down the numbers, right? So 195. Now I know 195 can be divided by 5, which means I can actually write like 195 is equal to 5 times 39. And the reason I know it's 39 is because I know 40 times 5 is 200. So that's how I kind of know it's 39 straight away. So, and if I look at the difference between these two numbers, it's about 34. But I'm actually looking for a 2. So what I could do is I could actually rewrite this as 195 equals 5 times, instead of 39, I can actually write this as 3 times 13. And when I do that, I can kind of see a pattern here, because I can then say 195 is equal to 15 times 13. And when I do 15 times 13, I can actually see that it has a difference between 2. So I've got my two numbers now, which means negative 2. So that means 15 has to be negative. So I got negative 15 and positive 13, negative 15 and positive 13. So once I do this, I need to split the negative 2. So I'm talking about this negative 2 here. I need to split it as negative 15 and 13. So when I rewrite this equation, I'm going to get 3x squared minus 15x plus 13x minus 65 is equal to 0. So at this point, what I want to do is I want to do factorize by parts. So first I'm going to factorize the two terms on the left of the green line. So that's going to end up looking like this. Whoa, what do we got? We got some movement here. So that's going to look like 3x and then x minus 5. And of course, I've got that little green part here. And now I need to factorize 13x minus 65. So I've got 13 as a common factor. And I'm going to get x minus 5 equals to 0. Now, because x minus 5 is a common factor between the two of them, I can take x minus 5 out. And what I get is x minus 5 multiplied by 3x plus 13 is equal to 0. So I've factorized it. So if I factorize it, now I know one of these brackets has to equal to 0. So I've got x minus 5 equals to 0, or 3x plus 13 is equal to 0. So x minus 5 equals 0, well, that's nice and simple. I can say x is equal to 5. But on the other one, I've got 3x equals minus 13, and then x is equal to, let me just put that in a different color. So minus 13, which means I get negative 13 over 3. So one of the things you need to realize is if x is 5, then I'm looking at here. The height can be 5, yeah? So 5 is like a tick. But you can't really have negative 13 over 3 as its height. So you can't really have a height of negative 13 over 3. And that means your area will end up being a negative number. Well, in this case, I'm just going to look at the height. The height cannot be a negative. So we write a little statement at the end. height can't be negative. Therefore, x is equal to 5 centimeters. So, if we were to look at grades, final answer gets you an excellence grade. Now for a merit, it says 2 above procedures. So 2 above procedures are equating to 65. So somewhere here, this is considered as an achieved consistent factorization of the quadratic into 2 brackets. So this could be another achieved consistent solving. This could be another achieved. So you've got like 3 options to get an achieved. But if you get 2 of them correct, then you get a merit for this question. And if you get your final answer correct, you get an excellence. Okay, let's go to the last question. Sorry guys, I know I kind of just messed up with the video there. But basically we've got this next question here. In 2018, day 1, when I did this question, I was thinking, man, this is quite a tough little question for you guys to do, because it had 2 simultaneous equation questions, and the names are a little bit funny as well. I'll tell you what I mean by. So first up, we've got 28 people in 2 groups that are going to a concert, and we've got students and adults. Now normally I'd say, yep, put A for adults and S for students, but the problem that we have here is we also have Samantha, who's got her own group. Now that's also going to be an S. So what I'm going to do is I'm going to replace students with the letter C. So I'm going to call them children. I don't know, just why not? Why not? So A is going to be adults, and C, I'm going to put that as students or kids, whatever you want. Okay, it doesn't really matter what letter you use, but just don't use S or J because that's Samantha and James's one. So what we have is we've got A plus C equals 28. And we know that it costs $600 but $20 for students and $25 for adults. So we can say 25A plus 20C equals 600. Okay, basically got that from here for this. So that's where this equation is coming from. And of course the 28 is coming from here. So our first step is to try and figure out how many adults are there, and then we can try and figure out how many people are in James's group and Samantha's group. So, so what we got is we got this first simultaneous equation that we actually need to work out. Now we've got, I want to actually do, I want to eliminate C. So what I'm going to do is I'm going to take the first blue equation and I'm going to multiply it by 20. So when I do that, I'm going to get 20A plus 20C equals 28 times 2, which is 560. So once I get that, what I can actually do is I can actually basically write these 2 equations, just subtract both of those equations separately. So I'll show you guys what I'm talking about here. So I'm going to write this equation down. Let's see, space is always a problem here. 25A plus 20C equals 600. But instead of writing minus, I'm going to actually change the sign for all of them. So I'm going to write this as minus 20A minus 20C equals, and then minus 560. Because when I do this, what happens is 25A minus 20A is 5A, 20C minus 20C is 0, and 600 minus 560 is 40, which means A equals 40 over 5, which equals to 8. So I've got the number of adults. The number of adults is equal to 8, and because we know that adults plus the students equals 28. 8 plus C equals 28. That means the number of students is equal to 28 take away 8, which ends up being 20. Okay. Now we go to the second part of the question. For the second part of the question, it says half of James's groups are adults. So I'm going to write that down here. Half of James's groups are adults. And then it says a quarter of Samantha's groups are adults. So that's a quarter of Samantha's group are adults. Now we know that there's 8 adults. So we're going to put down 8. But we need a second equation, and that's the number of students. So if the half of James's group are adults, then we know the other half of James's group is going to be students. And if a quarter of Samantha's groups are adults, then we know 3/4 of Samantha's group are students. So this is our second equation, set of simultaneous equations actually. And we want to actually eliminate it straight away because we've got half J here. So I'm going to take a different colored pen, and I'm just going to go minus, and instead of this plus, I'm going to change that to a, oh no, wait, no, let's not do that. Let's actually make it a little bit more easier for us. So what I'm going to do is I'm going to rewrite this whole equation as decimals, all right? But I'm going to write the bottom one on the top here, and I'll show you guys why. I'm going to write 0.5J plus 0.75S equals 20, and then 0.5J plus 0.25S equals 8. Now 1/4, 1/4, 0.25, 3/4, 0.75. And what I'm going to do is I'm going to subtract this whole thing. So 0.5J minus 0.5J is just 0. 0.75S minus 0.25S is going to give me 0.5S equals 20, take away 8 is 12. So what this tells me is 0.5. So half of Samantha's group is equal to 12 members. So that means, so if half of Samantha's group is equal to 12, then Samantha's group is equal to 12 divided by 0.5, which means Samantha's group is equal to 24 people. And if Samantha has 24 people in her group, and because there's only 28 people altogether, we can kind of say that James actually has 4 people in his group. And what did we know about it is that half of, so if you go back to the question actually says how many adults are in James's group. And we know half of James's group are adults. So half of 4 equals to 2. So therefore we can say James has 2 adults. So this question, as annoying it is, this question, you get an excellence for the final answer there. And you've got a whole lot of things that you can potentially do to get merit. So first thing to get a merit is if you get these 2 answers here, you get a merit, number of person in either person's group. You also get a merit at this stage here if you actually figure out how many are in each of the groups. And I think you get a merit even if you make mistakes, but you set it up nicely. For achieved, 2 equations correct. So if you have like 2 equations correct here, so if let's say you got these first 2 equations, you get an achieved. And also 1 equation correct and 1 variable eliminated. So if you find one of this here, you get an achieved. So, annoying question, I know. Let's go to question 2, folks. Guys, I do apologize. My voice is a bit croaky at the moment. We're gonna try and finish this because I know your exams are up in the next 4 weeks and people have been asking. But yeah, we just gotta excuse me with the coughing and clearing my throat every now and then. Okay, let's go to question 2a. What we got? We got a nice substitution question here because we've got to find a if x equals 3 and y equals 5. Find the area. So all I'm doing is I'm replacing wherever x is with a 3 and wherever y is with a 5. So a is equal to 3 times 2 times 3 squared times 5 minus 2 times 3. Simplifying this, I've got 3, 2 times 9 times 5 minus 6, 18 times 5, what do we got? 18 times 5, 18 times 5, 90 minus 6, 84, and then you get an answer of 252. Nice and simple, achieved right there. There's no alternative for this. Next question. What have we got here? Model of the top of the swimming pool is shown in the diagram. Perimeter of the model is 25x minus 2. What is the length of the side AB? Okay, so this is a classic perimeter question. You kind of start from one point and you add all the sides. So 1, 2, 3, 4 plus whatever this side is equals to 25x minus 2. All right. So what I'm going to do is I'm actually going to write down each of the things. I'm going to start with this one first. So I've got 5x plus 7. And I'll give you guys a bit of a hint in doing this question, all right? Rather than writing all this in like one big line, you can actually write underneath them. And I'm show you what I mean by. So then you've got 6x minus 3. So rather than writing, you know, plus 6x minus 3 here, what I would like to do is write it here. 6x minus 3. And then you got 7x plus 1. And then you got 4x plus 2. All right. I mean, if you really want to, you could even go the unknown here, right? Because the unknown AB, that's the AB, side AB here, is unknown. And then all of that adds up to 25x minus 2. Okay, this is a cheeky way of doing it, but trust me, it still works. Because then what you can actually do is have a look at it like this. Have a look at the x's, the coefficient x. So you got 5 plus 6, 11. 11 and 7 is 18. 18 plus 4 is 22. And because it's 22, you know that this number here has to be 3x. All right. And then you got 7 minus 3, which is 4. 4 plus 1 is 5. 5 and 2 is 7. So 7, what do you have to do to 7 to get to minus 2? Well, you got to do minus 9. So that's one way of actually doing the answer. The other way of doing this answer is actually just writing it all out the long way. So you've got 5x plus 7 plus 6x minus 3 plus 7x plus 1 plus 4x plus 2 plus AB equals 25x minus 2. So when you do this, what you end up getting is 22x on this side here. Because 22x is 5 plus 6x plus 7x plus 4x. And then 22x plus 7 plus AB equals 25x minus 2. So then AB is equal to 25x minus 2 minus 22x minus 7. Which means you end up with 3x minus 9. So grades wise, correct answer gets you a grade of merit. We've got establishing relationship, including AB. So I guess you want to set up something like this just to get an achieved. I'm not sure now, looking at whether this method, you know, it's still the same thing, but except it's done vertically like this and not horizontally. So I'm not sure whether it'll be accepted or not, but at least it's kind of like a quick way to check your answer. And then consistent simplifying of expression gets you an achieved. So if you, let's say, for example, you make a mistake, but then you get all the way to a wrong answer, you could get an achieved as well. Okay, let's go to the next question. So what we have is a classic simplification question here. So you got to factorize the numerator and the denominator. So with the numerator, you can kind of see that 3x is a common factor. So we write that as 3x, x plus 5. And the numerator is a difference of two squares, so we can write that as x minus 5 and x plus 5. Cancel out your common factors, and you're left with 3x over x minus 5. Now, this is one of those easy merit questions, because like that gets you a merit right there. Correct factorizing of numerator or denominator, so one of these gets you an achieved. All right, let's go to question D. So in D is what values of x will this equation work out? So this is very similar to the question I talked about earlier, but the only difference is you just got to write everything to this, so the bases all remain the same. So what I mean by that is 7 can be written as 7 to the power of 1 multiplied by 7 to the power of 1 minus x equals 7 to the power of 3x squared. Now remember this, when you have am times an, you write this as a to the power of m plus n. And so that's what we're going to do here. Because the 7 has the common base, we can write this as 7, 1 plus 1 minus x equals 7 to the power of 3x squared. So this could be rewritten as 7 2 minus x equals 7 to the power of 3x squared. And once again, because the bases are the same, you can write this as 2 minus x equals to 3x squared. So remember that if the bases are the same, then you can actually say the powers must equal each other. Once you do this, you can rearrange and write this as 0 is equal to 3x squared plus x minus 2. So at this point, we got to factorize. Now, if you're good at guessing and checking, you can go directly and put the two factors in there and kind of solve it. Or if you're like me, you want to mess around with this a bit with that old-fashioned way, then what you have is, so we do 3 times negative 2, which is negative 6. So we're looking for two numbers that multiply to negative 6 and add up to plus 1. The plus 1 is because from here, nice and small numbers to work with this time. So we can actually say 3 times negative 2. And that should be plus. And 3 plus negative 2 is positive 1. So when we rewrite this, we're going to write this as 3x squared plus 3x minus 2x and minus 2 equals to 0. So then we do that partial, like factorizing by parts. So we're going to get 3x x plus 1 and then minus 2 x plus 1 equals to 0. So our two factors are 3x minus 2 and x plus 1 equals to 0. So I'm going to go back here. 0 is equal to 3x minus 2 x plus 1. Now each one of these brackets has to equal to 0. So I've got 3x minus 2 equals to 0 or x plus 1 equals to 0. So 3x is equal to minus 2 and then x is equal to minus 2 divided by 3. So that's my first answer. Or my second answer is x equals to minus 1. Grades wise, we have excellence for the final two answers. Now it's one of those questions where if you get, I'm going to show you guys the 3 achieved parts, and if you get 2 achieved, you get a merit. So simplify indices on the left hand side. So this gets you an achieved. Quadratic 3 times. This gets you an achieved. And let's say you make a mistake from the quadratic and you come up with some answer, consistent answer, you could get an achieved as well. And if you get 2 achieved, you actually end up with a merit. All right, let's go to the next question. Gee wee, that is horrible. All right, guys. You know, this question is just friggin' frustrating. I'll be honest. The reason it's frustrating is because they've got so many names that they could potentially use. All right, there's 26 letters in the alphabet, and they have to pick 2 names that actually has R's in it. You know, just frustrating, that's all. Sorry, guys, to vent, but yeah. Anyway, I hope you had a chance to read through the question, but I think the key part is right here. It says Rani thinks that she's actually worked for more hours than Raj. I'm going to use the letters A for Rani. Actually, I'm going to use N for Rani. All right, so N. Now I can't use N because there's freaking N hours, so let's get rid of that. So I'm going to go with Rani for R, and Raj I'm going to go with J. So basically, Rani thinks she's actually worked more hours than Raj. All right, so we got a couple of equations there. The first equation is already given to us, which is Raj's work hours has been given to us here as n times n squared plus 8. And we got to try and work out Rani's equation. Rani's one is, it says, for the number of hours she has worked is the number n squared plus 10 times the number n. So this is going to be Rani's work hours. So that's Rani's. That's Raj's. All right. I mean, when you take out the words from this question, guys, it's actually not a bad question. But yeah, I guess I'm just frustrated with the fact that they actually use the 2 names that begin with the same letter. Anyway, let's go through this. So what we've got is n squared plus 10n. We want to know when is n squared plus 10n greater than n times n squared plus 8. Now, I want you guys to have a look at this particular point right here. The original equation that they gave us was a cubic. Now, majority of the time in level 1, you will be working with quadratics. And notice how they've actually kind of factorized this to show you that this could be written like this. Now, there's a reason behind it, because that means that they want you to do something like this here. I think it's a bit of a hint there. Because if you look at this question, normally if you expand this, you're going to end up with, I'm talking about right here. If you look here, you're going to end up getting like a cubic, and that's just going to be ugly. But because they factorized it earlier, what I'm going to do is I'm going to factorize Rani's equation. I'm going to write this as n plus 10 is greater than n squared plus 8. By doing this, what I can do is I can actually eliminate both n's. Now what I have is n plus 10 is greater than n squared plus 8. It ends up being a nice quadratic equation. Do one more step. 0 is greater than n squared plus 8 minus n minus 10. Which means I'm looking for when is this graph less than 0. So it's going to look like this. N squared minus n minus 2. Now this is where, you know, if you've done quadratic equations, it will really, really help you guys. Because what I'm going to do is I'm going to, and I'm not quadratic equations, I'm talking about quadratic graphs. So this is a quadratic graph, n squared minus n minus 2. Now you can factorize it, right? You can factorize this to be n minus 2 times n plus 1. All right? And I want you guys to imagine this. Now this particular quadratic, it's a positive quadratic. It's going to look like this. And it's going to have 2 roots. And its roots are going to be at positive 2 and minus 1. So that means I've got y equals to 0 somewhere here. And my 2 roots, negative 1 and positive 2. Now it's asking when is it going to be less than 0. Now remember that in a quadratic, for the roots, anything above the roots, the values are positive. Anything below it is minus or less than 0. So in this case, what we're actually looking for is when is this quadratic below 0? And you can kind of see that it's actually between negative 1 and 2. So you just write down it's between negative 1 and 2. All right, that's how you do this question. Grades wise, E for this grade. correctly gives consistent quadratic solutions to 2. So 2 solutions gets you a merit. So I would almost actually do this. I'd actually put down n is equal to 2 negative 1, just to make sure I get that merit. For achieved, correctly writing the inequations. So writing the equation gets you, oh, sorry guys. Writing the equation here gets you an achieved. What else? Correctly to a quadratic gets you an achieved. This one. Consistent relationship involving n. 2 solutions ignoring. Okay, so yeah, so you can actually get the 2 solutions for a merit, or you ignore the inequation and just get 2 solutions, also gets you a merit as well. So yeah, so if you haven't actually done particularly this type of question here, have a look at some of my previous videos, and I'm sure there's some questions like this on how to do these types of problems with the quadratic inequations. Okay, let's go to the next one. I'm conscious of time, guys. I'll try and get through this next part fairly quickly. So question 3a. So what we have is we've got sides of a rectangle and we want an area. So nice and simple. 3x minus 2 multiplied by x plus 2. What we have is expanding a quadratic. So we get 3x times x is 3x squared plus 6x. And then we've got negative 2 times x and positive 2. So what ends up being is negative 2x minus 4. But you got to simplify it. Don't leave your answer like this. Simplify it and you get 3x squared plus 4x minus 4. And that gets you an achieved. Let's go to the next one. 3b. It's one of those quadratics again, where we've got to solve it. So we got to factorize it first. So I kind of do this. 3 times negative 10 is negative 30. So I'm looking for 2 numbers that multiply to negative 30 and adds up to plus 13. In this case, 15 and 2, 15 and negative 2 works out. So I'm actually going to replace the 13 with 15 and negative 2. So this is going to be looking up like this. 3x squared plus 15x minus 2x minus 10 equals to 0. And I'm going to factorize by parts. So 3x and x plus 5 minus 2 x plus 5 equals to 0. And now x plus 5 is the common factor. Take that out, and I've got x plus 5 multiplied by 3x minus 2 equals to 0. Yeah, sorry about the voice, guys. Yeah, just struggling a little bit with this, but gotta get the job done, yeah? Go. So this is not finished yet. We've got to try and solve it. So we've got x plus 5 equals to 0, or 3x minus 2 equals to 0. So the first case is x is equal to minus 5. And then the second case is 3x is equal to 2, and x is equal to 2 over 3. So my 2 answers are x equals minus 5 or 2 over 3. So grades wise, final answer gets you a merit, and correct factorizing gets you an achieved. Both solutions consistent. So you kind of make a mistake, but you get an answer, incorrect answer, but you've kind of done the steps right. You could potentially get an achieved for that as well. All right, let's go to the next question. All right, guys. So with this question here, you've been asked to do a proof. So you've been asked to show the total of the 2 circumference of these circles is 24 pi. What I'm going to do is I'm going to kind of write this up a little bit just to give you a hint. Why is this not working? There we go. Now, I am going to call the big circle here and I'm going to call that radius as B. So that's radius of the big circle. And I'm going to call this radius of the small circle. All right, which means I can actually say, and I hope you guys can actually see this, because radius of B goes from the edge to the center here, and then radius of the small circle also goes from the edge to the center here. So what you literally have is RS plus RS plus RB plus RB. The whole thing is equal to 24 centimeters, because both the radius for the small circle plus both the radius for the big circle equals to 24 centimeters. So I can rewrite this as 2RS plus 2RB equals to 24. And because 2 is a common factor, I can actually take that out and rewrite this as RS plus RB equals 24, or RS plus RB equals 24 divided by 2, which ends up being, what do we got? 12. So RS plus RB is equal to 12. So once we get that, now we can actually work out the circumference of the circle. Because circumference of the two circles, you're going to have circumference of the small circle plus circumference of the big circle is what we're trying to figure out. Now we know what circumference equation is, because it's actually given to us right about here, 2 pi r. So I'm going to write this as 2 pi rs plus 2 pi rb. And because 2 pi is a common factor, I can take out 2 pi, which means it ends up being rs plus rb. And of course, we just proved that rs plus rb is equal to 12, which means we can rewrite this as 2 pi multiplied by 12, which equals to 24 pi. And if you notice, that's what our proof is. So basically that gets you an E grade. As for the achieved, there's quite a lot of things to do here to get achieved. So you could do it with diameter, you could do it with radius. So this could get you an achieved. 2 correct procedures from you. Yeah, there's quite a bit of combinations, guys, that you can actually get achieved in merit for. If I were you, I'd strongly recommend you to look up the schedule just to have a look at all the possible combinations. Because you can use this. I've done this question with using radius, but you can also use diameter for this question and do it that way as well. So there's a couple of different ways that you can potentially do this question. I'll tell you what, I'll see if I can get something that I did that went to merit. Second numerical calculation using 2 different pairs of radius. So somewhere here could potentially get you into a merit. I would actually say, yeah, but it kind of doesn't make sense, because if you get up to here, you probably will finish the question anyway. So yeah, not entirely sure. I'd actually ask you guys to have a look at the question, the schedule online. Okay, the second part of the question. Okay, now for the second part of the question, it actually says try and work out the difference between the two areas. Now remember that we actually worked out a relationship in the previous question, because we actually said that the radius of the small one plus the radius of the big one is equal to 12 centimeters, right? But instead of small and big, I'm actually going to rewrite this as radius of the first circle plus radius of the second circle equals 12 centimeters. All right? Because we need to find the difference in area for these two circles. That means we've got area of the first circle minus area of the second circle. Now the area of the first circle is going to be pi r1 squared minus second area one, which is pi r2, that's the second radius, squared. All right. What we do know is that we know that r1 plus r2 is equal to 12. So I'm going to rewrite r2 as 12 minus r1, because by doing that, what I can then do is I could actually replace r2 here with r1. So I'm going to end up with pi r1 squared minus pi 12 minus r1 squared. Okay. Now, if you are feeling uncomfortable with the r1s, you can just use r as is, if it makes it easy for you, but you're still going to end up with the same answer anyway. So I've got pi r1 squared minus pi times 12 minus r1 times 12 minus r1. So when I do this, I get 12 times 12, which is 144. 12 times r1 minus r1 is minus 12 r1. Then I've got another minus 12 r1. And then I've got plus r1 squared. So multiplying this with pi, I'm going to simplify that first before I multiply it with pi. So it's going to be minus 24 r1 plus r1 squared. Now I'm going to multiply it with pi. So I get pi times 144 minus 24 pi r1 plus pi r1 squared. And yep, I just realized my mistake. The first mistake that I made here was, this is correct, minus pi times 144 is minus pi over 144. But minus pi times minus 24 r1 should be plus 24. So I'm going to change that plus right there. And minus pi times r1 squared should be minus, not plus. Sorry about that, guys. So once we do this, what we have is pi r1 squared and pi r1 squared gets eliminated. And you're left over with just minus 144 pi plus 24 pi r1. So grades-wise, gets you an excellence. This is one of those questions where you get like 4 parts where you can get achieved, and if you get 2 of those correct, then you get a merit. So first one is forms an equation. So I'm guessing up here, achieved. Expand quadratic, would be about here. Simplifies and factorizes, which is up to here. So I don't get it, because like you'd be thinking that if you actually did this part right here, you'd get an excellence. Oh, I see. Okay, so you can actually factorize this further, and I think what they mean by is like, you know, even if you end up getting a wrong answer, you could actually have this written as what can you do? 24 pi negative 6 plus r1. So that's that factorizing part that they were talking about. So sorry, not this right here. So you could actually do 4 of these things, and I think 2 of them gets you an achieved, but if you do the full thing, then you get an excellence. Okay, let's go to the last question. I think I'm going to give my voice a break after that. Right, let's get to this last question here. So what we have is we've got another exponential question. As I said to you guys at the start of this paper is this: if you ever see exponential questions, try and write them as powers of the lowest number that you can find there. So you can kind of see that you've got base 3 here. And because you've got base 3, you can actually write 3 to the power of 1 is 3. 3 squared is 9. But here's the problem. And I've seen so many kids do this. They actually write down 3 to the power of 10 equals 30. Now guys, if you do that, it's not, you're actually not correct, okay? Because think about it. 3 to the power of 3 equals 27, and 3 to the power of 4 equals to 81. Okay, so don't write that 30 as 3 to the power of 10 like I've seen some kids do. So we're going to stop here, and we're going to rewrite 9 as 3 squared multiplied by 3 to the power of x minus 4, not equals, and it has to be less than 30. So because the powers are the same, we add them up. We're going to get 3x minus 4 plus 2 is less than 30, which gives us 3x to the power of minus 2 is less than 30. So, and I guess this is where you kind of need to go, well, what is the biggest number that you can actually put in here in terms of... So what I mean by that is, I'm going to kind of break this up now. So if I put 3 to the power of 3, is that less than 30? And then can I put 3 to the power of 4? Is that less than 30? So let's have a look. We know that 3 to the power of 4 is 81. And 81 is not less than 30. So that means this is actually incorrect. So the next best thing is that it has to be 27 is less than 30, which means that actually works out. So basically what we then have to say is that the power, and I'm talking about this power right here, this power, it can't be 4 because we know it's actually incorrect. All right, so that's wrong. But it can be 3. But it can also be 2. It can also be 1. It can also be less than that. So all we have to do then is just rewrite this whole thing as just saying x minus 2 is actually less than or equal to 3. Okay, so all I've done is I've said that the power, x minus 2, has to be less than or equal to 3. Because it can be 3, it can be 2. Because remember, if you have the power as equal to 2, then you're going to get 3 squared. And is 3 squared less than 30? You're going to get 9 is less than 30, which is correct. All right, and the same thing applies for 3 to the power of 1, 3 to the power of 0, and so on. So the simplest way to write it is that we actually put x minus 2 is less than or equal to 3. And when we do that, we've got a simple linear equation that we need to rearrange, which is going to look like 3 plus 2, which means x is less than or equal to 5. So this is one answer, or some people might actually do it with that it has to be less than 4. So the other way you could do it is, sorry, I got to go down to this other side here. Some people might say x minus 2 is actually less than 4 because it can't be 4. And if it can't be 4, then when we rearrange this, we're going to get x is less than 4 plus 2, which means x is less than 6. So you can actually give both answers, but I actually prefer this answer here. Yeah, the reason is because, I mean, we are assuming that the numbers are going to be integers here, because potentially you could actually have, you know, x to the power of, like if x is like 5.9, for example, I think it ends up being, no, hang on. So what I mean by that, that earlier statement that I don't like x less than 6 is because if x was 5.9, for example, then you go 5.9 minus 2 is 3.9, and 3 to the power of 3.9 is actually equal to 72. All right, so I guess that's one of the reasons why I'm not a fan of this particular answer, even though it's correct. You know, you have to assume that the numbers are integers and not like decimals and so on. So that's why I kind of prefer this answer here. But if you write either one of them, you still get an excellence for it. So this particular one is like you can actually guess and check in this question, but you got to do at least one correct algebra process somewhere. All right. So excellence is for the final 2 answers. For merit, this is one of those questions where you do like 3 achieved skills and you get a merit. So achieved for just writing this as 3 squared. You can also get an achieved if you do 30 divided by 3 divides by 9. All right, 30 divided by 9. So that's, if you do 30 divided by 9 here as another way, you could actually get an achieved. Right hand side in index form. That's interesting. I would actually say left hand side, but that's all right. I would actually, combination. So you get this as an achieved. And you also can get an achieved for writing somewhere x is equal to 5 rather than less than or equal to 5. So yeah, so if you get like 3 achieved things, you actually get a merit. All right, guys. I do apologize for starters for this video to be so long. As I mentioned, I was struggling with a bit of sickness for the last couple of weeks, but I don't think I've made things any better. My voice has just gone absolutely croaky. Normally I do this video in about 45 minutes, but today it's taken me about an hour. But yeah, so as for you guys that are watching all the way through the end, thank you for your ongoing support. If you could like, share, and subscribe, it would be really awesome. But more importantly, I think share this video to other people as well. And if you have any questions, pop it in the comments section below. And I do try and get back to people every now and then with questions that they have. Okay, so thank you for watching and all the best for this year's exam.